I believe we are back. Okay, chalo, cool. So next we'll do something else. Okay, multi BFS. Okay. Now let's take in kind of inspiration problem for this. Okay, and it's very famous. Okay. Okay, we have a. I won't say it is a grid because I'll make it as a story problem. Okay, what happened was one fine night they were decided to rob. They were decided to rob some houses, and he somehow finally got stuck here. Okay, so this is Deva, and obviously since he robbed, okay, uh, Deva, don't think anything. I'm just taking your name. Okay, and there are polices who are actually here. Like there are some police. Okay, there are some police, something like that. They are actually looking for this thief. Okay, no, there are some places where block. I mean, no one can go to. Okay, no one can go to. Same as blockage, whatever we have seen. So the thing is, since he has robbed something, he needs to escape this grid. Okay, police are looking for Deva, and Deva wants to escape the grid. Okay, now an escape is nothing but going out of the grid. Okay, if Deva manages to go outside the grid, he is safe. Police cannot catch him. But if somehow police catches him, then Deva will be caught. Okay, you have to tell me. Okay, there can be multiple policies. See, I have written there are three policies, right? So there are multiple police. There is not a single police. So there is one thief, there are multiple police, and there are some blocks, some cells which are blocked. This thief has to go outside the grid to become safe. Okay, each time he can either move right, the thief can move left, the thief can move down, the thief can move up. Okay, same for police too. Okay, you have to tell me, can Deva or can this thief be safely escaped from this grid? Is the question clear?
So
Yes.
police also can move, right?
Yes, police will definitely move because they have to catch him, right?
Same moves, right? Same speed.
Yeah, correct.
Yeah.
Okay.
So police will have single step, double step, or it's every time they'll go single step.
नहीं नहीं नहीं, सिंगल स्टेप, सबके पास मतलब भागने का ताकत एक ही है.
Okay.
Okay. Now, like the thing is, I mean, it's up to you. You want to run up to means like if you want to go, go. Otherwise, you can stay in that cell also. But somehow, if you be in that cell, somehow police will come and catch him, right? So you have to make sure कि भाई. Now the question is, can Deva safely escape the grid? Okay, that's the question. Question clear? Four of
Yes, bro.
Yeah.
Yeah, yeah.
nice.
Yes.
So
Yeah, bro.
think for something. I mean, think for a couple of minutes. What can we do? What can we do for maybe any other logic?
Like finding distance between police and thief,
Okay, and what
and if it is less than the both edges length, in that case,
edges length means?
like if
Border.
border, like from there to border, if you get difference of that.
So in this condition, can police catch Deva?
In this condition, no.
No,
No, because he will run from here.
to
Yes,
come
yeah,
back.
right side.
Yeah. So yeah, what you're telling, Sam, is like, can you explain with this example maybe?
Like we will be finding distance
Yeah, yeah. Tell.
between police and Deva.
Okay. So from which police?
Like from every police we will be finding.
Okay. From every police to Deva. Okay. And obviously we should not go via cross, right?
Yes.
Okay. Mm-hmm.
And if that distance is less than
Hmm.
distance between Deva and
Mm-hmm.
edges,
Which
like
edge?
corners, like all corners we will be checking.
Okay.
Okay, like in that case, blocks won't be. If
So
blocks are there, we
there
can't.
is a chance that like
Two
what
policies
yeah,
attacking.
there can be multiple scenarios which it fails, Sam.
Okay,
So we can like find the DFS from the Deva.
DFS or BFS?
BFS.
Okay.
It will give us shortest path, right?
Shortest path. Okay. Correct. Mm-hmm.
And we can find the BFS from police to Deva.
Okay.
If it is matching, it's not possible.
So I guess Sam also told the same thing, right? Like same thing, no? That you do a DFS from police to Deva, each police to Deva, and that's if the distance is somehow like greater than the he's escaping distance, he will run off. That's the same thing, right? So as he said. See, one thing is, so always what you are trying is to catch like this, right? But there might be a chance that this police might wait outside the grid, I mean at the boundary of the grid, right? And they will catch there itself. Does that make sense?
Yes.
Yeah, yeah.
Okay.
okay,
So what we will do is, so let's say uh Deva is here. There is this ending escape. Okay, ending escape. Deva will go like this. This is what he wants to do. If there is a police here, let's say as soon as this Deva is here, okay, if this police can somehow reach at this position somewhere above, I mean to the right of Deva, will he always catch Deva? If
Yes.
police reaches here quickly than Deva and Deva knows that this is my only optimal path, can I say police will catch him?
Yes.
Correct. Now there can be multiple like this, right? There can be multiple blocks, correct? Can I say if police is able to catch here, for sure he can catch here only. I mean, as soon as he escape point के पहले ही can he catch? If he is able to catch here at this position, for
yeah,
sure he can catch here also, right? Because he
yes,
can move more faster than Deva. He will stand here, Deva will come and Deva will be caught. True. Deva, is it true?
Yeah, yeah.
Okay. So somehow, unfortunately, you cannot, right? So the question which we are going to discuss is if somehow for all the boundaries for all the boundaries, if I can if we can calculate what's the minimum distance for any police to reach here, okay, for any police to reach here, if I can calculate out of all of them, okay, and for any of the boundary, if Deva reaches hmm, before any of the police, can I say Deva will safely escape?
Yeah.
Yeah.
yeah,
Right, that makes sense, right? If
yes,
out of all the police, let's say the minimum distance is p min, okay, let's say this guy is reaching in maybe for now, let's say this guy is here and he's taking 2 units of time, this guy is taking some 3 units of time, something like that, okay. If so the minimum time is 2, that is for sure in 2 minutes of time or in 2 units of time there will be a police. If they were able to reach at time unit of 1, can I say Deva will safely escape that? There is no one who can
Yes.
stop him, right? So what we will do in this problem is for each of the boundaries, we will try to calculate what's the distance that this policeman, I mean, out of all the policemen, what's the minimum distance they will take. Okay. Similarly, we will calculate for Deva also, that for Deva, how much time it will take for all the corners to reach. At any instant, at any cell, if it is allowed, I mean, if there is no blockage, And if Deva can reach faster than any police, can I say Deva will safely escape? Yes or no?
Yes.
Right? So that's it.
Hmm.
So this is what we have to do. Okay. Now the problem is you got the understanding, right? What we have to do. Correct?
Yeah.
Whatever we have learned, can I say I can do a BFS from each of the police and try to find the distance, corner distance, and update the minimum? Can I say that?
Okay. In that case, for every police, we need to check all the boundaries.
Correct. So for each of, because we need to find the minimum, right, Sam? Because
Yes. Yes.
someone is reaching at 5 units and someone is reaching at 3 unit and Deva is planning to go from there, then definitely that 3 unit guy will go and stand there so that
Yeah. Yeah.
he can catch. So can I say I have to do BFS from each and every police?
Yes.
Right.
Yes.
So the problem with this is, let's say there are many policies, and what's the complexity for each police? Uh,
B plus C.
just a minute. Just a minute. Yeah. So for each police, what happened, man? So why this drawing pad is not coming? Give me a minute, guys. There is some problem with OneNote. No, no. Yeah. So for each police, it's nothing but we go of V plus E, right? Correct. And if there are multiple policies, then it will be some, let's say the number of policies are X. Then can I say it is X into V plus E? Now, since we are dealing in a grid, what is V and what is E? I just told you in the
We,
previous session, we are nothing but this blocks only. So how many blocks?
yes.
How many blocks?
4 into n.
N cross M, right? That's all blocks. N into M ka grid. If there is N into M grid, then can I say N into M number
But
of?
but we only checking two walls, right?
Sorry?
Only corners, only bottom, right?
No, no, no. We have, let's say the police is here. Let's say the police is here. Then you have to do BFS from this only, right? And at the worst case, you will travel all the nodes. I mean, all the entire grid.
Okay, okay.
Although you have to find only these places, I agree. But you have to travel, in order to reach here.
Okay.
Mm,
So it will be, can I say N into M?
yes,
Yeah.
How many edges are there? So can I say, since the police or anyone can go only in 4 directions, can I say it is 4 into N into M? That from each block you can go to 4 directions.
yes,
So overall the time complexity is N into M, right? That is for each police. Now if there are multiple police, let's say there are almost same number of police N into M, then it will be N square M square, which will obviously exceed the limit.
Yes.
So this is where multi BFS comes and it rescues us. Okay. So what multi BFS says is, as the name suggests, it's multi. Multi means do BFS simultaneously from every police. Okay. Do BFS simultaneously from every police. Understood? So what we will do is, for each of the police, okay, this police is at, let's say, at 1 comma 1. This police is at, let's say, 3 comma 3, something like this. Okay. Something, there are some other policies also. Okay, let's say at 5 comma 1. So these are the three policies which we have, right? Instead of doing a BFS from each one of them separately, we will do at a time. Okay, and how we will do at a time we will see in the code. Okay, but is the intuition clear first?
Yeah, bro.
Others?
Same thing, but multi BFS, right? Just all performing at once.
And you know what's the difference, Sam? The difference is, instead of every time you remember, we will add a single node in a queue at the starting. Correct?
Yeah, yeah.
What here we will do is here we will add three of them at the same time. That's all.
Okay, before loops,
Before,
starting of
yeah,
loops.
before loop
Okay.
starts, because this will work same, right? Same as
Yeah.
BFS.
Okay, okay, okay.
So others, are you got the understanding, the idea of the problem?
Yeah, yeah. Got it, bro.
Okay,
Yeah.
Manan, Sam,
Yeah.
others.
Yes, bro.
Yeah.
Okay, so thief. Okay, so
Deva the thief.
उन्हें तुम्हारे को डिलॉयट आके मारता है तुम्हारे को नेक्स्ट टाइम. Okay, so I will not write the entire thing now, okay, because we need to cover others also. So what I will do is I will just write the method whatever is needed for us. Okay, is it fine for you guys?
Yeah, fine.
Okay, so
Yeah, yeah.
BFS. Okay, BFS में what we will do, we will pass a queue this time, or how shall we do? I mean, I just want to make it more extensible so that for both of them you can use it. That's what I am thinking of. Okay, let's take a list probably. Okay, list of pairs. Okay, list of pairs. uh, okay, now why list? Because there can be multiple police, right? That's what, that's the reason I have taken a list. Okay, and for Deva, since he will be a single element, but we will add it as a list. Okay, ठीक है? Now you remember what we need to do? Queue of pair, right? So we will create a queue. Okay, we will iterate on each of the positions. First thing what we will do is we will add it, and distance of p dot x, p dot y will be 0. Okay, is it fine? Are you guys able to follow this for loop? In the
Yeah.
queue,
Yeah.
initially we have added all the elements as like we discussed. Okay, and then it's a simple DFS again, which is night walk. Maybe we can take it from here. Okay, current text. Now instead of 8 directions, how many directions we have?
4.
4 directions. And do you
4
remember we have taken, I mean, there is was BFS 4 direction array. So
minus 1 0 1 0.
something like that. Okay, this one. See, this is the one for 4 directions. Okay.
Yeah. Yeah, I've seen. Yeah.
Oh shit. Pasted in the. Oh, did we paste? Yeah, correct. Yeah. Okay. So instead of this, we will write dx.
Dx dy.
Okay. So next x, next y. If it is valid, okay, and if the distance is new, then please add it like this, q dot add. Okay. So with this, can I say my BFS will compute the distance?
Yes.
Okay, and we need to, for this is valid to go next cell, what you can probably do is whenever you have a blockage, don't go there. Okay, so do you want me to write this method, or how do you guys can write this? Let me know, man, please.
That's checking boundaries, right?
Yeah,
No.
boundaries and blockage.
Yeah. Okay. We'll write it.
Okay. Okay,
How
bro.
it's
Others, can
How
you
will,
write?
Similar to that
what
one,
will you
just
write for blockage if blockage is there?
Bro,
it's similar to the unique
our
problem that
destination
we
is
have
border,
in.
right, bro?
Sorry, Sas, you are saying something.
Our destination is border, right?
Our destination is border. Correct. Border
Yeah,
matlab
why should we return
this one.
false in that case?
This one. These are the borders. Not outside. These are the borders.
Okay, okay.
Yeah. So Manan, you are saying this, right? You want me to, let's say, if it is not equals to blockage के लिए अपन hashtag use कर लेंगे, ठीक है? Hash
Hmm.
means blockage, ठीक है? So
Okay.
if we are inside the grid and if it is not a blockage, we are valid. We can go there. Now is it
Hmm.
fine?
Yeah.
Okay. Deva, you are saying something?
No, no. I was just saying this only. It's like similar to the unique path, right?
Same. I mean, not unique part, night walk.
Hmm.
So now are you guys clear what we have done?
yeah, clear.
Clear, right? So
Yeah.
what we will do is we will create a distance array for police, okay, and we will create a distance array for Deva, I mean thief, okay, and for each of the corners, okay, for each corner, okay, if Deva's time, I mean if Deva's x comma y, if it is less than police xy, can I say Deva can escape? Can we do this? Each corner मतलब क्या है? Go through these boundaries, that's all. This you can iterate now easily. These are only very less, right? M plus something, n plus n plus n plus n. That's all. Clear? Or do you want me to write? Do you want me to write this? Please, man, tell at least if you want, I can write.
Yeah, can you quickly write?
Okay, so we are going on each row. Okay, so for each row, this is what we are going through each row. This is zeroth column. This is m minus one's column, right?
Yes,
Correct.
yes.
If Deva of okay each row I0 is less than police of I0 or Deva of police of this should be
M minus.
N minus one.
maybe we can create one variable can escape equals to 2. Okay,
Hmm.
similarly for columns also, this is for rows you have done, right? I mean,
Yeah, columns.
yeah, for columns also. Okay, so now can is it understandable?
I think greater than, right? Deva of police is
Okay, you tell whether it should be smaller or greater. If Deva is reaching at 2 units and if police is reaching at 3 units, Deva will escape, no? So it should be smaller only, right? Let's say police is 5, Deva is 3, then will he escape, Sam?
no, he can't.
Arey bhai, he can escape, no? Who said he cannot? If Deva is reaching at 3 units of time and if police is,
Yes, yeah, got it. Yeah,
you are thinking in numbers. I mean, not like that. I mean,
Police. Yeah,
yeah,
police is
okay.
greater than there.
if someone
Yeah.
is having smaller means they can. Okay.
Yes, yeah.
So now is it clear, Manan and Sahas? Are you
Yes.
guys?
Yes.
Yes.
Yes. Yeah.
So you can write, na?
Hmm.
Hey, देखो, this is an incomplete code. I expect you guys to code in this and kind of send in the group or send to me personally, but no one does that. Okay, I don't see. So at least can you take this problem and write the entire code? मतलब पूरा.
Yes.
Yeah.
Yes, bro.
Okay,
TK, bro.
चलो ठीक है. So
Yeah.
this is what we have for multi BFS. So what you have learned in this is instead of doing a BFS from all, there is also this term multi BFS, which gives you the privilege or the power to do a BFS from all at a time. ठीक है, मतलब अब ऐसा ही सोचो कि भाई there are multiple viruses, ठीक है, there are multiple viruses, there is a city, and you have to kind of keep track of like what's the at which unit of time this city will get infected. So it's nothing but instead of doing a BFS from each and every single point, you can do a multi BFS. And since all of them will be queue at the same time, you will just do a BFS and you can do it in a single go, right? Instead of doing 5 BFS, you are done in a single BFS. That's the power of multi BFS. Okay. Okay. Clear?
Yes, bro.
Yeah, bro.
Yeah, clear.
Yes.